Hey everybody, happy Thursday. I hope you're having a really good week. So the plan for today is to continue with products with powers that we started yesterday when I did the notes in the video. And I told you you could get started on the assignment that was posted. So I'm going to go over some of those problems in the assignment. Maybe you struggled with it. It's not due until, I think it's due tonight, maybe I made it due Friday. I don't know, but it's not due yet. So if you want to go back and look at it, or if you submitted it maybe and didn't do well, you can go back and redo some of those problems and resubmit it if you want. And then we're going to move on and look at some more notes after that. So let's get started over here in Canvas. So it's on the very bottom of the page for today. Now, I've also published this one right here because after the notes today, if you want to get started on this practice, you can, but then I'll go over some of those problems in tomorrow's video, the quotients, okay? So we're going to start with the products with powers practice. I'm going to work some of those with you guys. Okay, it's not really a quiz, so keep that in mind. Canvas just calls it a quiz when it's in this format. So the questions I'm going to start with number 3. I'm going to do that one for you. Number 1 and 2 is pretty simple. It's pretty much like what I did in the notes. So I'm hoping you can figure those out. 3 I'm going to do, and then I'm going to do number 5, and I'm going to do number 6, and then I'm hopefully going to get to number 7. Those seems to be the ones that students have the most trouble with. And I want you to remember, because we went over the zero exponent, remember this is real important. So everything in the parentheses is raised to the 0 power. So everything in here, when raised to the 0 power, becomes a 1. So this whole stuff right here now becomes a 1. So you have to think 2 is multiplied times this stuff, which I just told you becomes 1. So you have to think, what's the answer of 2 times 1? I'll give you your answer. And this one right here, you can write all of these out, hopefully, and then maybe you'll see. I'm going to kind of talk a little bit more about what the shortcuts are as well. Try to do that. Okay, so here we go. So let's start with number 3. Let me pull up my iPad. So here's number 3. So here's the problem, and it's saying to take all of the stuff inside the parentheses and to square it, basically. It says it has a power of 2 outside the parentheses. So what that means is to write it down twice. Multiply all the stuff inside the parentheses times itself twice. So I'm going to do these a long way by expanding it out, and then I'm going to show you the shortcut at the end if you haven't already figured it out. So it means to say negative 4m cubed times, I have to multiply it times itself. So that's all the stuff in the parentheses, so I'm multiplying it times itself twice. Okay, so now we could do some more expanding. I'm going to move some of my numbers around too. So realize that when you have a number in front of a variable, we really could put a dot in between those. It means those things are multiplied. So this is really negative 4 times m cubed times another negative 4 times m cubed. So I'm going to separate them out. I have negative 4 times a negative 4 times an m cubed times another m cubed. I keep forgetting that my computer screen lags when I'm writing on the iPad like this. So I have to pause and let it catch up. Okay, so now I can expand this even more. Negative 4 times negative 4. And then m cubed just means to multiply m times itself 3 times. So that's m times m times m. Well, then I have another m cubed, so that's 3 more m's. Okay, perfect. So now I can simplify this. Negative 4 times the negative 4, well, that is negative times a negative becomes a positive, and 4 times 4 is 16. And then I'm going to condense all these m's back down. Well, I can count them. I have 1, 2, 3, 4, 5, 6 m's. So that really becomes m to the 6th. Okay, so now I'm going to show you, that's the answer right there. Now I'm going to show you the shortcut. Let me grab a different color. Here is the shortcut. So let's look. Originally up here inside the parentheses, the negative 4 right here does not have a power written on it. So anytime there's no power written, we know that it's 1 because -4 to the 1 is just -4. So if I'm looking and I say, well, okay, outside there's a power of 2 and there's a power of 3 here. And I can see that the final power on my m ended up being a 6. Well, that's the same thing as 2 times 3. So anytime you have a power outside of parentheses with powers inside, you can multiply those powers. So the 2 times 3 becomes a 6, and 2 times 1, well, that becomes -4 to the 2 times m, and 2 times 3 is the 6. So in the red over here is the shortcut. Well, -4 squared is -4 times -4, which is where we got the 16, and then the m to the 6. So same problem, it took me less than half the time because I used the shortcut. The shortcut is you can just multiply the powers, okay? Let's look at a different one. Let's talk about a different shortcut. Okay, so here I have j to the 5th times j. So I'm going to start by writing it out. I have j times another j, because j to the 5th means to multiply j times itself 5 times, and I have one more j stuck on there. Okay, so now all I have to do, and this one doesn't take long to work out the long way, I just have to count how many total j's do I have and put a power. Well, I have 1, 2, 3, 4, 5, 6. So this is j to the 6th. But look, I could go back up here, let me get my other color, and say, well, this is j to the 5th, and this one is j to the 1. What is 5 plus 1? 6. There you go. So when you have a base multiplied times the same base, notice they were both j's, you can just add their powers together. That makes sense because I know I'm going to have to write down 5 j's, and I was going to write down one more j, so I got a total of 6 j's. J to the 6th. Okay, let's look at this one. This one gets confusing for students as well because the parentheses. But I want you to remember, parentheses just mean multiply. So we could rewrite this as 2 times x cubed times 4 times x squared. And that's what that's saying to do, is just multiply everything. So then I want us to think, well, I'm going to let my computer catch up here. Don't we know what 2 times 4 is? 2 times 4 is 8. And then I'm going to think about this. If I have x cubed times x squared, now I could go along and expand this out. X cubed is x times x times x, and x squared is times x times another x. So this is going to end up being 8x, and I have 1, 2, 3, 4, 5. But here's the shortcut again. Look, I knew I was going to have to write 3 x's and then 2 more. So I could have just added those up and gotten x to the 5th. 3 plus 2 gives me the 5. That would have been the shortcut, and I wouldn't have had to write all that out. So let's look at one more. Negative y to the 5th times negative 2y to the 10th. Again, parentheses just mean to multiply, guys. So this is the same thing as negative. Now remember, there's no number in front of the y written, so we know that number has to be 1. So negative 1 times y to the 5th times negative 2 times y to the 10th. That's how you can think of it. And we know what negative 1 times negative 2 is. Negative times a negative becomes a positive. 1 times 2 is just 2. So now I have to figure out my y's. Well, let me grab a different color. If I was going to write these out in a big long string, I would have 5 y's that I had to write out and then 10 more. So how many total y's would I be writing out? 15. So there's your answer, 2y to the 15th. Okay, so that's showing you the shortcuts and also showing you the long way to do it, where you just expand it out and kind of write all of them out. You can do it either way. You should come up with the exact same answer. One of them does take longer, but if it's harder for you to see the shortcut, then just keep expanding it. There's no problem with that. Okay, so now I'm going to go over some notes with you. So let me come back over here to the modules page. because I want to remind you where we're getting these notes from, right? So these are the notes. Here we go. Right here on Tuesday. Third quarter journal setup. So if you click that and make a copy of that file, that's where I'm getting these notes from. So let me pull those up over here. There we go. Okay, so that's where we left off yesterday. So we're going to start with Unit 6, Lesson 4. It'll catch up with me. Quotients of Powers. So this is basically what we were doing yesterday, expanding things out. We want to see what the trick is. There's got to be a shortcut, right? So there's another shortcut here. Yesterday, hopefully you saw, let me go back up a little bit here, that when we were expanding these things out, there we go. For instance, this one, we saw that we had the powers of 5 and 3, and we got 8. So we saw that we could add the powers together. X squared times x to the 7th became x to the 9th. Because again, I was going to write 2 x's and then 7 more, and that's how I got the 9. So we're still using that same idea, but that was when we were multiplying things all in a line. Well, now on this one, we're going to be dividing. We have some quotients here. So quotient just means division problem. Okay, so they've done the first one for us. So I'm going to start off and I'm going to do some of these with you, but I'm going to leave some of them for you to do on your own. So 3 to the 7th times 3 to the 4th. I'm going to skip that one, and I'm going to skip down to this one for you. X to the 7th divided by x to the 4th. Okay, so x to the 7th means I would have x times x times x 7 times. 1, 2, 3, 4, 5. Okay, I think I got all of them. Divided by x to the 4th. Well, that's x, 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 x. Now, this column over here that says simplify, I'm not going to rewrite this and simplify it over here, guys. I don't need that column. I don't need that for this problem right here. So if you don't need to use both those columns, that's okay. So what we need to remember is that when we have a number divided by the same number, which the simplify up here actually is not written. So like for instance, if I was to take 2 up here and divide it by the 2 on the bottom, well, 2 divided by 2 is just 1, isn't it? And remember, 1 times anything doesn't change the number. So this is, and you have to remember back when y'all were working with fractions and simplifying fractions, like you started back in like 5th, 6th grade, you can cancel these out. It's because 2 divided by 2 is 1. Well, there's another 2 divided by another 2, and that's also going to be 1. And 2 times 1 is just 2. So this simplifies down to just 2 to the first power. So we can do this with our x's as well. Well, I have 1x divided by this x on the bottom will be divide out to be 1. This one divided by this one is another 1. This one divided by this one, 1. This one divided by this one is a 1. I'm only left with x times x times x on the top. I canceled everything out on the bottom. There's only a 1 left on the bottom now. So I could put all this over 1, but I don't have to. Well, x times x times x is x cubed. Okay, remember we're looking for patterns here. So we're paying attention to our powers. I had a 7 and a 4, and I ended up with a 3. So let's pay attention to this, see if we can find this shortcut. Okay, so now I'm going to work the next one with you. 5 cubed times y to the 5th over 5 squared times y squared. So I'm going to start by expanding the whole thing. 5 cubed is 5 times 5 times 5 times y to the 5th. That's 5 y's divided by, let computer catch up again. I really do not write that slow, guys. It looks like I write so slow. Okay, let's do the denominator. 5 squared is 5 times 5, and y squared is y times y. Okay, so now I'm going to come along, and I'm going to do some canceling again. This 5 divided by this 5 cancels out, divides out to 1. This one can cancel with that one. Okay, I still have a 5 left. Y divided by y divided by y, and I still have some y's left. They happen to all be on top. Again, so the only thing left on the bottom is now is a 1. Well, 5, I have 1 5, and then I have times y times y times y. So I can simplify this. this is going to become, ooh, my thing is like frozen, I think. 5y, well, y times y times y is 3y's, 5y cubed. Okay, so again, I want to look and see here what's happened with my powers. I ended up with a 5. So remember, the power on the 5 right now is a 1. Okay, it's not written, so it's a 1. And a 3 on my y, and these are the powers that I started with. 3 and a 2 and a 5 and a 2. Hopefully you are seeing some shortcuts here. Is there a pattern to this? Okay, so I'm going to let you do the next two because they're very similar to what I just did. And I'm going to do the A7B squared, that one, the very, very last one down here. I want you to fill in the rest of this table. Okay, so I have a to the 7th. Okay, so that's A times A times A times A. I got to write out 7 A's times B squared. That's B times B. So that's my top fully expanded. Okay, so now I'm going to expand the bottom. A squared times B to the 6th. Well, that's A times B. I have to do 6 B's. I think I got them all. Yeah. Okay, so let me let my computer catch up. Now we get to do some canceling. I love doing these, so I love to cancel things out. Okay, so I have an A can be divided by an A. Another A divided by an A. That's all my A's I can cancel. I don't have any more on the bottom. I can cancel out some of these B's, though. Oh, okay, so looky here. I'm left with 1, 2, 3, 4, 5 A's on the top. 4, 5. And then I'm left with 1, 2, 3, 4 B's on the bottom. That's all I had left. Great. Well, I can simplify this now. On the top, I'm going to have A to the 1, 2, 3, 4, the 5th power, divided by B to the 4th power. So let's look again and see what happened. Let's look at our powers here. So up here, looking at this one, I'm seeing that I ended up with a 3, and I started with a 7 and a 4. Well, how do you take 7, 4, and 4 and get 3? Well, don't you subtract? 7 minus 4 equals 3. Over here on my 5s, I had a 3 and a 2. So 3, I'm at this problem now. 3 minus 2 gave me the 1, that's really on the 5. And 5 minus 2 gave me the 3. Okay, so remember our very first one we talked about how when things are multiplied, we're adding our powers. So now, and it makes sense, it's opposite, we're dividing. So we are actually subtracting our powers. And it happened here too. 7 minus 2 gave me the 5. And 2 minus 6 actually would give me a negative 4, but I'm thinking I'm subtracting them the opposite. I really am saying the 6 minus the 2 on top gives me the 4 on the bottom. So you always leave it where the bigger one is because you have to think, well, I only have 2 B's on top. They would cancel out. I'd be left with B's in the bottom. But we still subtracted them, 6 minus 2. So I want you to fill in the rest of that table. I think you can do it. So we're seeing we can subtract some powers. Well, now I want to move on to this one. Okay, so they did the first one, and they said, well, all right, you have things divided inside parentheses. So let me do the second one for you. 3/5 squared. Sorry about the bell. Okay, well, that means to say 3/5 times 3/5. So now we're back in. We have things being divided inside parentheses. Well, that's the same thing. I'm going to expand this out further as saying 3 times 3 on the top, because that's how you multiply fractions. Multiplying fractions is no big problem. It's the top times the top and the bottom times the bottom. And then we can simplify that. 3 times 3 is 3 squared, and 5 times 5 is 5 squared. So this is interesting. I'm looking and I'm saying, okay, this first one, there was a 4 on the outside of our parentheses, and it looks like that 4 was applied to the top and the bottom numbers. Same thing happened here when we just did this. So let's jump down to this 2x over 9 cubed. Okay, so that means to say 2x over 9, and I'm going to drop parentheses this time, and I'm going to use a dot instead, times 2x over 9 times 2x over 9. Well, I could simplify this even further as 2 times 2 times 2 times x times x times x. I'm rearranging them like we did yesterday. I'm going to put all my 9s together. Because remember, that's how you multiply fractions. You multiply all the tops, you multiply all the bottoms, you make a big fraction. Well, this is really the same thing as 2 squared. Oh, I'm sorry, not squared. There's 3 2's there, so that's 2 cubed times x cubed times 9 cubed. Now notice on day 1, we saw that when we had stuff in parentheses raised to a power, we really were multiplying all those powers, taking the power outside the parentheses and multiplying it times the powers inside. And it seems to be the same shortcut here. We have to multiply them times the powers in the numerator of the fraction, and we have to multiply them times the power in the denominator of the fraction. So this really is not anything new. So I'm going to do this next one, and then I'm going to leave the last one for you guys to do. I'm going to fully expand it out. We're going to make sure this is true before we come up final. Okay, so I have 3a squared over 12b times 3a squared over 12b, because that's what this is telling me. Take all this stuff inside the parentheses. Let my screen catch up here. So take all this stuff inside the parentheses here and multiply it times itself 2 times. That's what I just did. Okay, so this is the same thing as, let me do my 3's, 3 times 3 times, well, I'm going to end up writing 4 a's, right? Because I have an a and an a squared and then another a squared over 12 times 12 times b times b. Okay, so now let's simplify it. Let's bring it back down. Well, 3 times 3 is the same thing as saying 3 squared. Now, we could multiply that out and get 9. You're right, we could. But for this sake, we're just going to leave it as it is. When we're working our problems, our final answer, we do want to go ahead and multiply that out and get 9 over another number on the bottom. But we're trying to see patterns here, so we're going to leave them with powers on them. So a times itself 4 times is a to the 4th over 12 times 12, well, that's 12 squared, and then b squared. So let me get a different color, and let's go back and look here and see what our original powers were. So I'm going back over to this side. Okay. So I want us to look. Notice the 3 right now doesn't have a power written, so it has a power of 1. It's important to notice that. 12 doesn't have a power written, so it has a power of 1, and the b also does not have a power, so it must be a power of 1. So look, it looks like what we did was we said 2 times 1, we got this power. 2 times 2, and we got this power. 2 times 1, we got that power. And then that 2 on the bottom, and we got that power. So it's true. It is true. That is the shortcut. So if you want to do this bottom one by using the shortcut, I am okay with that. There's a lot to write out if you're going to expand it. But it will expand exactly the same way. It is the answer. And you can even verify these by putting this problem like here in the calculator and then go ahead and putting your answer that you get on the other side in the calculator. They will be the same answer. So this is another shortcut. This is very similar to the shortcut that we talked about in yesterday's video at the end of the video. But this is what it is. When you have a power outside parentheses, you multiply the powers times all the powers inside the parentheses. You just have to remember when you have something like this one right here. Let me zoom in a little bit. This 2 actually has a power of 1. The x actually has a power of 1. Even though they're not written, they have powers of 1. So you're actually multiplying that power on the outside, the 3, times those 1s. So that would be 2 cubed x cubed over 9 cubed. And that's what we got when we expanded it out and we saw over here our final answer. Okay, so the whole point of this is for hopefully to let you see these shortcuts, why they work and why they make sense. And I'm going to give you a list of the shortcuts. You do not have to memorize them, okay? But what I want you to understand is that if you can't memorize them, if they confuse you, go back to writing it all out. Yes, it takes longer, but you'll always come up with the right answer if you can expand it out fully. So they're actually on the STAR formula sheet. So I'm going to work on getting that uploaded onto Canvas. So you have the STAR formula sheet to look at when you take quizzes and things like that. So be on the lookout for that. And then go ahead and try to start working on that assignment that I put on there, the Quotient with Powers practice. And I'll probably go over some of those problems in a video tomorrow if you're struggling with those.